Okay, now we're going to look at what happens when we don't have any variables that line up in elimination. If you take a look at both of these equations, 2x and x, neither one of those have the same coefficient. And if we look at 5y and 3y, neither of those two have the same coefficient. So we can't just subtract them to eliminate a variable, and we can't just add them to eliminate a variable because neither one of them are the same coefficient and opposite signs. So we're going to have to do something different. And what we're going to do is we're going to multiply one of the equations by a value that will make the coefficient the same as one of the coefficients in the top equation. So if we take a look at the two variables, it's not easy to turn a 3 into a 5. However, it is fairly easy to turn a 1 into a 2. So we're going to multiply the bottom equation, the entire equation, by a -2, so we can then add to eliminate the x. So we get the following. The -2 is on the outside of the parentheses, and we're going to distribute that -2 to each term inside the parentheses. Now, before you do this, make sure off to the side you make a note of what the two original equations are so you can come back to those later, because you're going to have to do a substitution back into one of the originals. And once you multiply by -2 on the denominator, on the bottom equation, that is no longer the original equation. So I'm just going to stick these up here so I remember them later. So the new equation I get is -2x plus -6y equals -16. Now I'm ready to add the two equations and do substitution like I've done in the past. Elimination like I've done in the past. So when I add these two equations, I get -2x and +2x are 0, and +5y and -6y are -1y, and 10 minus 16 is -6. Dividing both sides by -1, I get that y equals 6. So now I have to go back and plug this y equals 6 back into one of my two original equations to find out what the solution was. So I'm going to take x plus 3y equals 8 and use that as the equation I try. And I'm going to plug 6 in for y, and then I'm going to solve this equation for x. Why don't you pause the video and find out what x equals. So by doing the rest of the algebra, we can see that x equals -10. We now know our intersection point. Our intersection point is -10, +6. Please pause the video and copy this into your notes. Okay, now it's your turn. Look at the two systems of equations above. Please pause the video and find the intersection point. Here's the solution. As you can see, we multiplied the top equation by -2. We got -6x plus -4 equals -10. Then we added the two equations with 3y equals -6. Dividing by 3, we got y equals -2. Then we substituted back into 3x plus 2y equals 5. By solving that equation, we get 3x equals 9, which gives us x equals 3, and an intersection point of 3, -2. Please pause the video and copy this into your notes. Here's another set for you to try. 5x plus 4y equals 3, and 3x minus 2y equals 4. Please pause the video and find the intersection point. Here's the solution. As you can see, we multiplied the bottom equation by positive 2. That enables us to change the bottom equation to 6x minus 4y equals 8, thus giving us a positive 4y and a negative 4y, such that when we add, we get 0. 5x plus 6x is 11x, 3 plus 8 is 11, divide by 11 and we get x equals 1. Then we need to substitute back into one of the two equations. When we substitute back into the bottom equation, we get 3 times 1 minus 2y equals 4, and solve that, and we get y equals negative 1/2. So the intersection point is at x equals 1, y equals negative 1/2. Please pause the video and copy this into your notes.